Okay, this problem says, which of the following integrals converge? Okay, so this problem shouldn't take as long as you might think. By the way, the Roman numerals are a little weird, so that's Roman numeral 1, this is a Roman numeral 2, and there's 3. Okay, so the idea here is essentially to compare these to p-series whose behavior you know. So, for example, the first one, the integral from 4 to infinity, okay, so that's going to be, according to the limit comparison test, which you shouldn't use here, like directly, you shouldn't actually write it out, that's too much work. Is a multiple choice, we kind of want to arrive at the right answer quickly. So it's going to behave like a p-series we recognize and memorize. And so to quickly get at the answer, you want to know, pluck out the highest degrees there. So that's x squared over 5x cubed, which is 1 over 5x. So even the 1/5 doesn't really matter because that's not going to affect convergence or divergence. So put it in or don't, doesn't matter. Okay, but we recognize this as one that diverges. Okay, so 1 is not, so 1 is out. Okay, we go look at 2. So this is the same idea, the integral from 9 to infinity of x over x squared plus 4x plus 8. Okay, we're going to say that behaves like a p-series that we recognize. So, right, the numerator behaves like x, just be careful. The denominator behaves like x squared to the 5th, which is x to the 10th. So that's 1 over x to the 9th. Okay, which we recognize as a convergent p-series. Okay, so 2's in. And so we got to get rid of anything that doesn't have 2. So now it's down to 2 or 3. So 3 is the integral from negative infinity to negative 5, 1 over x to the 8th. Okay, so most of the textbook definitions and the theorem, they don't really discuss so much the negative part of the x-axis, right? Negative infinity to negative 5. That might throw you a little bit here for 1 over x to the 8th. But like if the astute math student, if you're curious, you might notice that like all of these graphs we're looking at, they have some sort of symmetry, and this is 1 over x to the 8th, so it's going to look like this over here. Okay, but it's an even function, which means that it reflects over the y-axis. If that was 1 over x to the 7th, it wouldn't. 1 over x to the 7th would have an arm down here. Okay, so it would have a rotational symmetry. The conclusions would still be the same, but let me just get rid of that, just not to confuse you. In any case, they all sort of have that behavior. So what are we looking at? The integral from negative infinity to negative 5. This isn't to scale or anything. It's just a quick sketch. What you notice is that, like, by symmetry, that's going to be the same as the integral from 5 to infinity. These areas are going to be precisely the same. Okay, let me just comment on that. 1 over x to the 8th is an even function. Okay, which means like it's symmetric over the y-axis, and that those areas match. So I could say like this behaves like the integral from 5 to infinity. Okay, and we recognize that as one that converges. And so that means 3 is in, which gets us our final answer of E.